Welcome. In today's lesson, I'm going to be showing you how to generate the inverse of quadratic function. And the objective is, by the end of this lesson, you will be able to know how to restrict the domain of the quadratic in order to make the inverse a function. So if I ask you to generate the inverse of this particular function, x plus 3 squared plus 1, there are many methods that I can use to generate the inverse. So for example, we can graph this function and then pick some few points on the graph, just like this. Those points that we picked, we can put them into a table. Then we can switch the x and the y value of the table to generate the inverse. After you switch the x and the y, you can then plot the switched x and y coordinate point back on the graph and join it together, and that will be your inverse. So if I now ask you, do you think the inverse is a function? So use your vertical line test, and the vertical line test shows that definitely the inverse is not a function. So the question is, how do we make the inverse of a quadratic to become a function? So we can do that by restricting the domain of the function. When we say restricting the domain, what we mean is we can cut the quadratic into two equal parts at the vertex. When you cut the quadratic into two equal parts, then the inverse is also cut in half. So that makes the inverse to become a function. So when we cut it, so the domain of the left part become x less than or equals to -3. So the bottom half of our inverse is the reflection. So that will be the inverse. If I choose the right part or the right half of the quadratic, then the top will be the inverse. So as you can see, if I choose the left, the inverse is going to be a function. Or if I choose the right, the inverse is now a function. So up to this point, we don't know what the equation of this inverse is. So let's generate the inverse by following these basic 4 steps. So you want to, the first step says we should change the f of s to y. So this becomes y equals to s plus 3 squared plus 1. So then we want to solve the equation for x. So we can move this positive 1 to the left, so it will become a negative. So that will make our equation to become y minus 1 equals to s plus 3 squared. So to be able to remove the square, okay, we need to take the square root of both sides. And when you take the square root of both sides, you need to put the plus or minus, okay? So the square root takes out the square. So now we are left with, that. So now I also need to move the positive 3 to the left. It will become a negative. So at the end of the day, we have y minus 1, the square root of y minus 1 minus 3 will be equals to x. So all we now need to do in step 3 is to switch the x and the y. So we are not changing the equation. We are just switching the x and the y. Wherever you see the y, you change it to x. So this is going to become plus or minus x minus 1 minus 3 equals to y. So this is now the equation of the inverse, okay? So now that we have the equations, as you can see, we have two equations, one positive and one negative as the inverse. When you split or you divide the quadratic into two, in this case, you are selecting the right part. So that means you are restricting the domain to be x greater than or equals to -3. So the inverse will be the top. The top is the positive. So this is the positive part. So remember, when you choose the right, you are looking at the positive square root function. So and then when you choose the left, so in this case, as you can see, the domain is x less than or equals to -3, that is going towards the left. So the inverse of this left half will be the bottom. So, and please remember that this is the negative square root function. So to solve this particular question, so we are given this function. So you also want to know that in this question, you have a negative square root function. You have a negative. So that means this is the bottom. Okay? This is the bottom half. So that means for the bottom, then I'm looking for the left part of my quadratic to be the inverse of it. So that means I cannot have anything greater than, because I'm looking for something that goes towards the left. Okay. So I cannot have this two. So you can already eliminate E and F. I want to now find the equation of the quadratic. So we want to solve for X. We can square both sides. So we have y squared equals to negative x plus 2 square. So y square will be, so negative square will be positive, because negative 1 multiplied by negative 1 will be positive 1. And square root of x plus 2 square, again, you know that the square is going to cancel the square roots. So that gives us x plus 2. So the positive 2, if you move it to the left, that becomes negative. So that this becomes x squared minus 2 equals to x. Then you switch the x and y. So this becomes x squared minus 2 equals to y. So as you can see, the inverse of this function is x squared minus 2, not negative x squared minus 2. So h is wrong. So in that case, G is our solution. So in this question, you are given this function x squared plus 1. And you are told that the inverse is this. So we are also given the graph. So we are now being asked what restriction of f of x, that is the restriction on the domain. The restriction on the domain, not restriction on the range. We allow it to be the inverse of g of x. So we have to cut the quadratic into 2 equal parts. So this, for it to be the inverse of the negative. So the negative again will be the bottom half. The bottom half will be that half. So that means we want the left. We want the left part. So we want s less than or equals to 0 in this case. So as you can see, the option A and B is asking you to restrict the range. So we know that that cannot be the answer, okay? Because what we want to do is to restrict the domain. And option C is also saying we need to choose the right part, the right half of the quadratic. But we know that that is wrong, because we need to choose the left to be able to be the inverse of the bottom. So at the end of the day, option D is the correct solution. So this question says, are these two functions inverses? So what I want you to pay attention to again is the negative of g of x is the negative part of the square root function. That means it's going to be the bottom half, okay? And this one, s greater than or equal to 1, that will be the right, because again, the inequality is going towards the right, so this is the right part. The right half of the, so can right and the bottom, can they be inverses? So the answer in this case is no, they are not inverse. So you can also graph both of these, okay? So this is the graph of f of x. So this is the f of x, okay? So if you graph it, so you are looking at the right half, and then this is the bottom of the g of x. So this definitely, they are not inverses. So thank you so much. I hope you enjoy it. Please remember to subscribe. Have a nice day.